Assalamualaikum warahmatullahi. Apa khabar? How are you, everybody? Hopefully, all my students in Principal Communication System class is doing very well at the moment. Okay, so today's class is about, we will continue our discussion in new chapter, which is chapter 3. Yeah? Okay. Okay, chapter 3, angle modulation. Angle modulation. Learning outcomes. After studying this chapter, the student should be able to explain the concept of angle modulation, describe the differences among analog modulation scheme, analyze amplitude modulated signals, the time and frequency domain, analyze amplitude modulated signal in time domain and also frequency domain. Okay. Analyze frequency modulated signals in frequency domain. Describe phase modulation. Explain the need of pre-emphasis and de-emphasis of frequency modulated signal. Okay, next. So basically, this is the contents of chapter 3. Okay, part 1, which is now angle modulation, which divided into FM and PM. So FM is frequency, okay, F, and P is phase modulation. M is modulation lah. Frequency and phase modulation, FM and PM. Basic principles of FM, which is frequency modulation. Frequency deviation, you have maybe you have come across this concept. Modulation index, M. We have seen this concept in amplitude modulation, previous chapter. Bessel function, this is new. Power analysis. Okay. The next part, and then we will discuss about bandwidth, how to calculate bandwidth of frequency modulation using Carson rule. What is narrow band and wide band. And at the end of part 1, we will describe a little bit of the comparison between the advantages and disadvantage of AM versus FM. The advantages and disadvantages of amplitude modulation compared to frequency modulation. Okay, so the second part of this chapter, we will discuss about FM transmitter, the transmission of the FM signal, and also the FM receiver, the receiving part of the FM signal. And last but not least, some discussion about noise calculation in FM, in pre-emphasis and de-emphasis part of the FM signal. That one will be later. Okay, so analog modulation. Okay, so analog modulation, not amplitude. So analog modulation can be divided into two. one is amplitude modulation, which is we already discussed in chapter 2. And now chapter 3, we will discuss about angle modulation, which is can be divided into two. First is frequency modulation, FM, and the second one is phase modulation, PM. So amplitude modulation is the process of varying the instantaneous amplitude of carrier signal accordingly with instantaneous amplitude of information signal. So this is amplitude. You have amplitude, amplitude, amplitude. Okay, so the frequency modulation is the process of varying the instantaneous frequency of the carrier. Okay, compared to this one is amplitude of the carrier. So this is instantaneous frequency of the carrier signal accordingly with instantaneous amplitude of information signal. So now frequency modulation is, what is frequency modulation? Process of varying the instantaneous frequency of carrier signal. Okay, frequency of carrier signal. Okay, phase modulation is the process of varying the instantaneous phase of carrier signal. So now you have amplitude of carrier signal, amplitude modulation, frequency of carrier signal, frequency modulation, phase of carrier signal, phase modulation, with instantaneous amplitude of information signal. So all these compared to amplitude of information signal. Same. Okay, so phase modulation and frequency modulation is part of angle modulation. Okay. Angle modulation is often called frequency and phase modulation, FM and PM, because of its superior performance compared to amplitude modulation. It is used extensively for commercial broadcasting, radio broadcasting, television sound transmission, two-way mobile radio, cellular radio, microwave, and satellite communication system. So these are example of application for angle modulation. Okay, FM and PM. So you must be very used to hear about FM, especially in radio broadcasting. We have example Pahang FM, right? Era dot FM, tapi era dot je kan, era dot je, iKim dot FM. So all this using frequency modulation. FM is probably the most commonly used analog modulation technique, seeing application in everything from broadcasting to cordless phone. PM is rarely used in analog system but is very common in digital communication. So we will discuss about digital communication in another part of this maybe the next chapter 4. Okay, so let's see, this is the signal, the information signal, where you have the amplitude and time. This is the time domain of signal, time domain of analog signal. You have amplitude versus time. Okay, this is low frequency, low frequency. So in carrier, this is the representation of normal carrier signal, which is high frequency. So if you compare this carrier signal with information signal, or we call it baseband signal, the carrier signal having very high frequency compared to the baseband or the information signal. Okay, so after the frequency modulation process, we will get this kind of signal, which is we call it FM signal, frequency modulated signal. So you can see there is change of frequency in this output signal, where this part having high frequency compared to the carrier signal, because in this part the amplitude of the information signal is high. Okay, whereas here the amplitude is low, so you will have the frequency of the output here lower compared to the carrier signal, the original carrier signal. Okay, we will discuss about this later. Okay, so now you need to you can see that this the typical output of FM signal, where the frequency varies. Okay, some part of it having high frequency, represented by this short distance peak. Okay, and another part of the signal is having lower frequency, represented by this further part of the peak in the same signal. Okay, so you can remember, so this is the baseband, this is the carrier, and this is the output of frequency modulated signal. Okay, frequency modulation. The frequency of the carrier wave is changed according to the information signal. The frequency of carrier, so we have seen before, the frequency of carrier wave is changed accordingly to the information signal. Waveforms that are more spaced apart represent the valley of the sine wave. Waveforms that are close together represent the peak of the sine wave. Okay, so if the output more space apart, maknanya the frequency is lower, so it represent the valley. The valley ni meaning the lower part of the amplitude, the negative part of amplitude, sine wave of this information signal. If the output waveform are close together, the peak is close together, it represent the peak or the positive peak of the information or the baseband signal. Okay, ya, terbit lagi gambar ni. So this is the peak, this is the valley. So if you see this peak, the output is, the peak is close together, meaning this is having high frequency, this part. And if this is the valley, the lower, the negative part of the amplitude of the information signal, so this signal, this is space apart. The distance is far, so it represent the valley or the lower frequency of this phase signal. Okay, phase modulation. Here the phase of the carrier is altered according to the information signal. Waveforms that are close together represent the sine wave transition from negative to positive. Waveforms that are more spaced apart represent the sine wave transition from positive to negative. Okay, so this so if you have this negative, this is positive to negative, it has more higher frequency. Okay, so this phase modulation we will discuss later after the frequency modulation. Okay, AM, FM, and PM waveform. Can you spot the difference? Okay, given that there are several type of signal, right? So here we have MT. This is the information, the baseband signal, low frequency signal. So this is the carrier. Carrier, we have high frequency signal. And AM, we have discussed, we have learned about this signal in chapter 2. So for amplitude modulation, the signal is in the form of envelope, right? This is envelope. The frequency is constant, but the amplitude changes. So the amplitude of the signal, AM signal, changes according to the amplitude of information. So this amplitude, peak here it peak, low here is low. Okay, so hopefully everybody still remember about this. The second one is FM. So FM, frequency modulated signal, you have a peak here, so you have high frequency here, you have valley here, low part of the signal, so you have low frequency here. So this is far apart, is representing the low frequency of the signal signal. Okay, for PM, when there is change from positive to negative, then there is a high frequency. Change from negative to positive, there is low frequency. Okay, it's look like similar, but it is not. It is not. So it is not similar. But don't worry, we will discuss about PM after we finish FM. Okay. Okay, so angle modulation. The angle modulation can be expressed mathematically using this equation. Vt, this is the FM signal equation. Vt equal to EC cos 2 pi Fc t plus pi t in bracket. Okay. So what is represented by this equation? So EC, kita dah biasa tengok kan, this is a carrier, the amplitude of the carrier. EC is peak carrier amplitude in volt. Okay, apa lagi? Kita biasa tengok. Cos, biasalah, cos kita tahu. 2 pi Fc. Fc is the frequency of the carrier, okay? Fc is carrier frequency in Hertz. Vt dalam kurungan V dalam kurungan T is the angle modulated wave ataupun kita panggil FM signal ataupun PM signal in T time domain. This is T time domain. So Vt equal to EC cos bracket 2 pi Fct plus theta t. What is theta t? Theta t is the instantaneous phase deviation in radians. Theta t is the function of the modulating signal. Theta t equal to F Vmt. Theta t is the frequency of baseband or information signal, where Vmt, this one, Vmt is Em sin 2 pi Fmt. So we have discussed about this in previous chapter, right? The equation is similar. Vm, the information signal or the baseband signal or the data signal, equal to Em. This is Em. Em is amplitude of modulating signal sin 2 pi Fm t. 2 pi Fm. Fm is frequency of modulating signal or the information, frequency of the information signal. Boleh So this Vmt is here, is in this part. Angle modulation. The choice between FM and PM depends on which one is directly varied by the modulating signal. Direct FM, varying the frequency of a constant amplitude carrier signal directly proportional to the amplitude of a modulating signal. Direct PM, varying the phase. Varying the frequency. Varying the phase of constant amplitude carrier signal. Carrier signal ni memanglah dia constant amplitude. Directly proportional to the amplitude of a modulating signal. whichever property is directly varied will cause the other property to vary as well, yeah. So PM or FM, for FM, instantaneous frequency of the carrier frequency is varied from its reference value by an amount proportional to the modulating signal amplitude. Frequency carrier directly varied, phase carrier indirectly varied. Phase angle of the carrier is varied from its reference value by an amount proportional to the modulating signal amplitude. So this is phase angle of the carrier. Sama ini frequency of the carrier. Phase angle of the carrier is varied from the reference value by an amount proportional to the modulating signal amplitude. Phase carrier directly varied, frequency carrier indirectly varied. Both must occur whenever either from an angle modulation is performed. Both must occur whenever either form of angle modulation, either it is PM or FM, is performed. Okay. FM or PM. This is the carrier. This is called the, what do you call it? The constant amplitude carrier signal. This is called constant amplitude. This is constant, right? The constant amplitude is here. Plus N, plus V, and minus V. So the amplitude is constant. Constant amplitude carrier signal. Modulating signal. Modulating signal is low frequency modulating signal. Okay, so if FM, the frequency, the high amplitude of the modulating signal will produce high frequency for frequency FM signal. Low amplitude, low frequency, produce low frequency for FM signal output. So on and so forth. For PM phase modulation, so changes in phase. For example here, negative to positive, high frequency, positive to negative, low frequency phase signal. Okay, so so that's all for the introduction of angle modulation part 1. So we will continue later the next part of this basic principle of FM. So until then, hopefully you can understand. We will continue after this. Thank you very much for your attention. Okay, so we will continue after this. Okay, bye-bye. Assalamualaikum.